Good morning. In this video we'll study about the solenoids and its properties. First we'll learn about the solenoids. What is solenoid? It is an insulated copper wire wound around the cylindrical is known as solenoids. Here you can see the solenoid. It is an insulated means this copper wire it have a cover. It's insulated and it is wound around, it means it's winding around. When we pass the electric current, then it produces a magnetic effect. Like we have this magnet, it have north pole and south pole. Inside there, the magnetic lines are parallel from north pole to south pole. Inside the solenoid, it flows from south to north, and outside it is just opposite again. How will you know that it's a north pole or south pole? If the current is in anti-clockwise direction, this side is a north pole. On the other hand, if the current is flowing in clockwise direction, it is a south pole. It can be remembered with the help of this. With the symbol like capital S. And the north pole also, it can be remembered like capital N. How it's flowing, based on this we can determine whether it's a north pole or south pole. Here the current is flowing in this direction, that is anti-clockwise. Then you can see here the arrow mark, the current is flowing in an anti-direction, that is north pole like capital N. And once again, south pole, if the current is flowing in this direction, clockwise direction, then it is a south pole. Now we'll study about the strength of magnetic field inside the solenoid. Strength of magnetic field increases on increase of current, that is B is directly proportional to I. Strength of magnetic field B is increases number of turn. If number of turn is more, then the strength also increase. This is also, we can say that B is directly proportional to N. Magnetic field B is also directly proportional number of, here we can sum up, directly it is proportional to N into I, that means number of turn into current. In other words, we can learn that when a copper wire is with a resistive coating is wound on a chain of loop like a spring, it is called solenoid. Resistive coating means insulated. Whenever an electric current passes through a solenoid, it behaves like a magnet. One end of the current acts as a south pole, while the other end acts as a north pole. The magnetic field line is from south pole towards north pole, inside and outside from north pole to south pole. And inside it flow in parallel and they did not intersect each other. We can see that the similarity between the bar magnet. The property of magnetic field is very similar to magnetic field produced in the bar magnet. The magnetic line inside the solenoid are parallel to each other. This indicates that magnetic field is same inside the solenoid. Okay, we'll learn how to make a solenoid. You take a very long coil and make it circular turn, that is like cylindrical. It should be a insulated copper wire, and this is what you see, that is solenoid. when we pass an electric current, then after observing, we have observed that it have magnetic field. The magnetic field is like what we have observed in bar magnet, which have north pole and south pole. And inside, if you observe carefully, they are parallel to each other and they're flowing from south to north, and outside they are flowing from north to south. They have the same magnitude. If we suspend freely in the air, then it will point northward and north and south direction, like the bar magnet. And now let's check application of this solenoid. When we insert a piece of soft iron core, the iron piece is pulled inside. When the current is withdrawn, then it moves out again. This is used in several electrical appliances like doorbell, starter of the vehicle, including dishwashers. In many applications we are using in day-to-day life. When a current carrying solenoid have a iron core inside, it behave as, that is what we call electromagnet.